Good morning, class. So today we're going to talk about applying the first derivative test. Now, functions can have certain attributes. If we look at a function, we can look at its slope at a certain point, the tangent line slope as we've been calling it. I can have tangent line slopes that are negative slopes, and I can have tangent line slopes that are positive slopes. And functions can change. They can have moments where they have a constant or a zero slope. Okay? Now, in a function, if I go from this negative slope to this positive slope, what do we call this point on my function? We call it a relative minimum. And then same thing goes if I were to have a positive slope conversing into a negative slope, leaving me with this moment of a constant slope. I would have a relative, well, you guessed it, a relative maximum. And then, of course, we can always have functions that don't change. For instance, look at this function. This function has a positive slope, a constant slope, but then it goes back to another positive slope. We say this function is always increasing, or monotonic. Oh gosh, monotonically increasing. It just means it's always increasing. And same thing goes, I can have a function that has a negative slope, and it can even stop, take a little break, have a constant slope, and then carry on his way with another negative slope. And we say this function is always decreasing, or it's monotonically decreasing. Okay? Now, we can find all this information out by using the first derivative test. We're talking about slope a lot in this unit, and lucky for us, the first derivative gives us slope. So I have the following function. F of x is equal to x cubed minus 6x squared plus 15. And we would like to find the location of the relative maxes and or the relative mins. It could have one, it could have the other, it could have both. So let's take a look at this. The first thing we want to do is we want to solve for f prime, the slope function. And this is going to be a very simple derivative. I'm not even saying it because y'all know exactly what it is. And we get our derivative, 3x squared minus 12x. Now, we talked about critical points. And we said critical points are what happens when I take my derivative and I set it equal to 0. Remembering, this means slope. And this says slope is equal to 0. Flashback, what did we say was happening at this point right here? My slope was constant, or slope was equal to 0. So, what we're finding with our critical points is our possible points of min and max. It doesn't have to be, because for instance, this slope was 0, but it was not a min or a max. So let's find our critical points. Well, luckily for us, we can factor this. It factors quite nicely. We can take out a 3x, and that's going to leave me with an x minus 4 on the inside. Again, this means I have two math problems. I have the math problem that says 3x is equal to 0, and I have the math problem that says x minus 4 is equal to 0, meaning that x is equal to 0 and x is equal to 4. Okay? So what we can do with this statement is say these are my critical points. These are my critical points, and I can analyze them on a number line. So let's come over here and make a number line. I want to use my critical point of 0 and my critical point of 4. Again, I want to write down CP. These are my critical points, so I don't forget. And now I can take a number around these. Let's take a number less than 0, maybe negative 1. I'm going to take a number between 0 and 4, maybe 2. And let's take a number greater than 4, possibly 6. 6 is a number that is larger than 4. Okay? And I've chosen these numbers on my own will, whatever I wanted to choose. Now, I need to plug these numbers in. Now, I'm looking at slope, so when I plug these numbers in, when I say I'm going to plug these numbers in, I'm looking at slope, so let's plug them into f prime. Okay? Now, I can come down here and compute f prime of negative 1, f prime of 2, and f prime of 6. Remembering that my f prime equation was 3x squared minus 12x. So let's show that. That's going to be 3 times negative 1 squared minus 12 times negative 1. This over here would say 3 times 2 squared minus 12 times 2. And this down here would say 3 times 6 squared minus 12 times 6. Okay? Let's go through and solve all these. 3 times negative 1 squared is a positive 3. And then negative 12 times negative 1 is a positive 12. That gives me a positive 15. Now, I am very happy about the fact that this number is positive. And I don't really care that it's 15 so much as that I care that it's positive. So that means we have a slope that goes up. Now let's plug in my 2. 3 times 2 squared is 12 minus 12 times 2. Well, that's 12 minus 24. 12 minus 24 gives me negative 12. Again, I don't really care what the number is. I just care about the fact that it's negative, meaning that I have a downward slope. And finally, 3 times 6 squared is a big number. Hang on. I don't have a calculator next to me at the moment. It's 108. And 12 times 6, again, I apologize. I probably should have done this ahead of the game. So I'm doing 108 minus 72, which I know is a positive number. Positive number, meaning that I have a positive growing slope. Okay? So what does this tell me? Well, this tells me a couple of things. I now know intervals of increasing and decreasing. I know that my function is going to be increasing from negative infinity to 0. And I know it's also going to be increasing from 4 to infinity. That negative slope means my function is decreasing from 0 to 4. And now I know a couple of things. I know that I have a relative max when x is equal to 0. And I now know I have a relative min when x is equal to 4. Now, how do I know that? Well, I was growing, I was getting taller, then I was constant, and then I was getting smaller. And then I was constant, and then I was getting taller. So we see these levels of relative mins and relative maxes in our function. And that's pretty cool. So, applying the first derivative test, sorry, I was going to say application, and then I wanted to say applying, and it came out applying. It's kind of weird. But applying the first derivative test tells us not only intervals of increasing and decreasing, but it helps us locate relative maxes and relative mins. So let's try one on your own. It's going to be a beefier problem. Go ahead and find the location of the relative maxes and relative mins of this one. I suggest you guys pause this video and try it out yourself. All right, welcome back, guys. Let's see how we did. So the first thing you should have done is you should have found f prime of x. Now, this being a rational function, it's got a numerator and a denominator. Taking f prime involves a quotient rule, right? We're going to the club today, guys. So low, d high, well, the derivative of this is going to be 2x minus 2 minus, and before I get carried away, I need to give myself some more room, minus high d low. Well, d low is nice. It's actually just 1, isn't it? All over low, x plus 1 squared. Okay? Now, before we used to always say stop here, and I'm actually going to insist that we simplify it for our benefit. So let's simplify some things. I can go ahead and multiply these two binomials together. I'm going to use a FOIL technique to multiply these two guys together. I'm going to get a 2x squared minus a 2x and plus a 2x. I'll show it. Minus 2x plus 2x minus 2. And then I also want to make sure that I distribute this negative sign to everybody in that trinomial. So minus x squared plus 2x minus 1 all over x plus 1 squared. This is, some of y'all are excited, you're jumping for joy. This is pretty fascinating. If you're not, I recommend you try it out. These two guys right here, they cancel because one's positive and one's negative. We have some like terms that we could simplify. Right there. And I can write this as 1x squared plus 2x and then minus 3 all over x plus 1 squared. Okay? This is my f prime. F prime of x equals. Now, we took a derivative, and hopefully what we did is we set it equal to 0. Okay? Now, when we take a rational function like this and we set it equal to 0, the first thing you can do is you can multiply your entire denominator up. But multiplying by 0 lands you just with 0, don't we? So you should have got x squared plus 2x minus 3 equals 0. This is nice. It's a quadratic. We're excited. We can factor it. This is happy days. So we can say x plus 3 and x minus 1. And this gives me two math problems. We agree? This gives me the math problem that says x plus 3 equals 0. And it gives me the math problem that says x minus 1 equals 0. Meaning that x is equal to negative 3 and x is equal to positive 1. So what we just found is some critical points, right? That x is equal to negative 3 and x is equal to positive 1. But let's remember one thing about critical points. We say critical points happen when the derivative is equal to 0 or when the derivative is undefined. Well, the derivative is equal to 0 here, and we just proved that. But where might the derivative be undefined? Well, a function is undefined if we're dividing by 0. And do you think when x is equal to negative 1, we would be dividing by 0? We would. So we want to make sure we include all of these critical points in our problem. Let's take our critical points and make a number line. I should have had a negative 3. How about a negative 1? And maybe a positive 1. And let's pick some numbers around these. I'm going to go with maybe like a negative 5, a negative 2, probably a 0, and then maybe a 6. Something on the right side. And we're going to plug these points into what? We're plugging these points into my f prime because we want to analyze the slope. Okay? So hopefully you guys got here. And let's see if I can tell you guys what happens. After we plug them in, I recommend calculating this. You should have gotten that. Let's see here. I did the problem. I gotta look at my notes. You should have seen that over here we were a positive value. Over here we were a negative value. Over here we were also a negative value. And finally over here we were a positive value. Okay? Again, I told you guys, you're going to see the alternating pattern a lot, but do not assume that they always alternate. Okay? So that means this guy is increasing, this guy is increasing, and these two right here, decreasing. Okay? So what do we notice? Well, I notice that means I have intervals of increasing from negative infinity to negative 3, and then again from 1 to infinity. And I have intervals of decreasing functions from negative 3 to negative 1, and then again from negative 1 to 1. And actually, because it's all together, we could have written that if we like to. We didn't necessarily have to stop. We could have said just negative 3 to 1. That would have worked as well. And then finally, right here, I'm going to have a max, and right here, I'm going to have a min. So let's write that formally. We're going to say I have a relative max when x was equal to negative 3, and I'm going to have a relative min when x was equal to, oh no, I lost my scroll bar. Pause. X is equal to 1, when x is equal to 1, okay? These are applications of the first derivative test. Hope you guys learned a lot. Take good notes. You have homework tonight. Work on it. If you have any questions, feel free to email me or post on Edmodo. You guys are awesome. Keep rocking it. Adios.